Have you ever looked at metro tracks and wondered, are these things actually electrified? And if yes, why don't trains just explode the moment something goes wrong? Today, we're diving deep into one of the most invisible yet powerful systems of modern cities. How metros and trains get their electricity, how the systems differ, and why some of them can be extremely dangerous. Buckle up, because once you learn this, you'll never look at rail tracks the same way again. Let's start underground with metros. Most people think the two rails on the ground carry electricity, but surprise, they don't. Those are just the running rails for the wheels. The real electricity comes from a completely different place, depending on the city. And globally, metros use two main systems. System 1, the third rail, the hidden power source. The third rail is literally an additional metal rail placed beside the tracks. It carries 600 to 750 volts of DC electricity, and the train touches this rail using a contact shoe under the train. It's compact, powerful, and perfect for underground tunnels where space is limited. Cities like New York, London Underground, Moscow Metro, Tokyo Metro, some lines, all use the third rail system. But here's the important part. The third rail is always live when trains are operating. Touching it is fatal. System 2, overhead wires, the metro style used above ground. Not all metros use the third rail. Some cities, especially modern or above-ground metros, use overhead catenary wires, just like regular trains. The train uses a pantograph, yes, that big metal arm, to collect power. Overhead systems are common in Paris RER, Hong Kong MTR, certain lines, Istanbul Metro, newer lines, light rail and tram networks worldwide. These lines can carry either DC or AC electricity, depending on design. And unlike the third rail, overhead lines are safer for people on the ground, but more sensitive to weather and require more maintenance. What about trains? High voltage, high speed. Now let's go above ground, to regional trains and high-speed monsters like the Shinkansen, TGV, and IC. These trains use almost one universal rule. The longer the distance, the higher the voltage. Why? Because high voltage means less current, less loss, less heating, and dramatically more efficiency. This is why high-speed trains often use 15,000 to 25,000 volts AC from overhead wires. The pantograph connects, electricity flows, and the train rockets forward smoothly. Countries using AC overhead systems include almost all of Europe, Japan, Korea, and China. Safety. What are these systems dangerous? Let's talk danger, because some systems are safer than others. Third rail risks. The third rail is the most dangerous type of electrification because it sits right where people can fall or step onto it. Even a few centimeters of accidental contact is enough to be lethal. That's why platforms are fenced, tracks are sealed, tunnels have restricted access. Overhead wire risks. Overhead wires are safer for pedestrians because they're far above reach. But they're exposed to storms, ice, wind, metal fatigue. A broken overhead wire can shut down an entire corridor, and it happens more often than people think. So, do metro and train tracks have electricity? Absolutely, but not in the way people imagine. The two rails you see are usually harmless. The real electricity comes from a deadly third rail or powerful overhead lines. Metros choose what fits their tunnels. Trains choose what works best for long distances. And now that you know how these systems work, the next time you step into a metro or watch a train speed by, you'll understand the invisible power that keeps them alive. If you found this video helpful, like it and subscribe so you don't miss future videos.